We are continuing with Zoran Horvat. Zoran is an exceptional person and quite an expert in the Agile world. He is leading, he founded and is leading the Coding Helmet Consultancy, and I've tried to count the number of articles he's authored. I gave up very soon, but there is over 100 of them. On top of this, Zoran is very often presenting at conferences like this one and very often delivering trainings to people who want to become more successful in their Agile career. Zoran will be talking to us about some very technical and specific topics. It will relate to how to translate our user stories into code, how to understand big problems and make smaller chunks of them so we can actually address them. Zoran, welcome.
Thank you.
And if I was not technical enough, I will kindly ask you to clarify quickly so as to manage the expectations of the audience what the presentation will be about.
Yes, this presentation will be about how to manage user stories. But on the front side, it will all be code because I don't like managing too much. I like to write code. So the accent will be on how to write code, and we will write code that satisfies user stories because customers expect that and customers will verify that.
Great, awesome. So code it is. And before we move into code, Zoran, is there anything particularly interesting, memorable, or relevant about you that you would like to share with us? Just so we get to know you a little bit better.
Yes, if you want to know me better, I don't know. This is a time of epidemic measures, and we are running conferences from homes. So don't be surprised if my cats start piling up toys on the desk while I speak.
Awesome. So we have a cat person here. Everyone be aware. Great. Zoran, I'm giving the floor to you for the next 30 minutes. Audience is all yours and you are all audiences. And then everyone in the audience, please remember to put in your questions for Zoran. And we will spend the last 15 minutes of our session today with Zoran answering your questions. So make sure they're tough questions. Make sure they're, questions that will help you do your work better and that will help Zoran demonstrate his expertise. So Zoran, over to you.
Thank you. I will share my screen. You will see the title, Problem Decomposition Techniques for the Agile World. So, as I said, it will all be code. The demo application will be Blazor WebAssembly in C#. But don't worry if you're not accustomed to C# or if you're not accustomed to WebAssembly, which is quite new technology. Don't worry, you don't have to understand every single line of code, but please focus on the process in which code is evolving. That will be critical here. I will show you the application. It is an amusing example which I'm extensively demonstrating in the last couple of days, months. Maybe you have already seen me play tic-tac-toe in conferences. So here is another conference where I will play against myself and I will win, of course. So this will be the example application to which our customers will add requirements and we will have to cope with those requirements. Science Those are another two elements. And when the game ends, you will see a line, which is the fourth element, design element we will have to deal with. And eventually notice that all blue the customers are in the where the home player played and where the away player played, so that X and O signs can be drawn. It is also exposing a sequence of winning lines, which can be empty or contain one or two winning lines. So that is the fourth element displayed in the UI. And this is how a move is made. So there is the play method on the board, which receives a coordinates of the cell that was clicked on the screen, and it will generate the new board position. Notice that all elements in this design are immutable. That will help a lot. This is just a side note. I will tell you that I favor immutable design a lot. Virtually all my classes start off being immutable, and they might become mutable only if there is a serious reason to. One of the reasons that happens is performance. Another reason is that the design and two. And that is the entire model. This is the UI. You will recognize a loop which is adding clickable cells, those active blue squares that you can click, and home cell and away cell components as many times, and in those places where home and away player played. And there are the lines, the winning line component, which will also be drawn if present on the screen. So this is the UI. And here is the backing code for the UI, which is handling the click event and telling the board to play. So this is the entire application. Okay. As I finished speaking, the customers have arrived and they are ready to tell us the requirements. This is the address where you can download initial and final code. So please visit this GitHub repo and download code if you want to see everything. I will not show everything to you because of there's no need to show every single line of code. Anyway, the requirements. We have a working game in production. It is very nice, but it also only lets me play against myself, which is not really funny. The customer said they want us to implement computer player so that the user can play against the computer. And there we are. There is a definition of done, so that there is a player which plays intelligently against human player. It is not really precise. Definition of done is not really precise. Why? Because nobody, including customer, really knows what they expect other than very broad sentence of I want to play against the computer. This example may look like a toy example, and it is, but try to relate what I'm showing you here with what you are seeing in your industry code. Customers will rarely be specific, because if they were so specific, they would already have the code that does what they want. They will ask you to develop a feature, but you will have to investigate that feature. And as you do, you will stumble upon many, many surprises, bad ones included. For example, how fast does that computer player need to be? How aggressive, how intelligent? This user story says nothing about that. And on top of everything, we don't even have a representation of a player in our game. So we are lacking infrastructural code to support any feature like this. And so if you gave this task to a junior, they would probably say, oh, yes, we are going to develop a computer player. Let's start. And start with what? How will anyone estimate this user story? How will anyone be able to promise to deliver this user story by the end of the sprint? It's impossible, because there are so many unknowns in this single user story that we cannot commit to it. And that is what this presentation will be about. If you want to commit to a user story, it must be entirely clear. If you want to estimate the duration or the effort you will invest into this, into implementing this user story, if you want to be certain that definition of done will pass at the end of your work, you need to know more. And so instead of jumping onto this user story, committing to it, opening it for work and starting working, you want to introduce multiple other user stories that will, in fact, clarify this one and define it. You know that habit of customers to jump in the middle of the sprint and change the user story. Do you know when that happens? They rarely do that on their own because they just want to jump in and change your user stories. It is probably because something happened, probably coming from development. Somebody told them, oh, we discovered this thing. And the customer will say, oh, that affects the rest of the requirements. Let's change that user story and make this new discovery affect it. And so we come to that stage where customer is changing requirements in the middle of the sprint. You don't want that to happen, and you stop that from happening by not committing to user stories which you do not see all the way through. This one, playing against computer, tells us that we need another one. Players. We don't have explicit player model in this code. So I might introduce, and this is the technical user story, customer doesn't even need to know about it. I want the team to develop explicit player models. before doing anything else. And those models would effectively model humans at the first stage, not computers. But if we ever wanted to implement a computer player, we had to have a player first. So let's practice on humans. I see entire code which implements this. So I can, because I know the model already, so I can estimate this user story, I can commit to it, and I can deliver it. I know I can. Once we do this, we might implement a computer player, but not the intelligent one, a stupid one, but automated. And once we complete that, we will have two kinds of players, one being a computer. So we need to substitute that computer with an intelligent one. I think that these three additional user stories are breaking down the user story number one into chunks which we can estimate, commit, and deliver. And once we do, we hope to be able to also promise to fix up whatever loose ends we have and complete user story number one, but not now. Only after we finish all three user stories, these technical user stories, only then shall we sit with the customer and talk about the major one. And so we take this one, model iterative, interactive players explicitly. Look at the definition of done. Nothing changes. The point of this user story is not to add a feature, but to prepare a ground for a feature. So don't shy away from having user stories with definition of done, nothing changed. Because once you deliver that user story, deliver code to production or to testing, you will ask the customer, do you see anything new? And if they say no, you will say, yes, that's what we wanted. So we continue. If they say, oh, no, this thing or that thing has changed, you will say, oh, that wasn't supposed to happen. So let's see why we changed behavior of the application. So we have a user story which says develop or model explicit players. To do that, again, you don't have to read every line of code. If you are in C# or can understand C#, download code and read everything later. I think what I saw when I was reading that user story number 2 is that board should not be the one who controls the game, but there should be a model for the game. And game would give us the board position to draw. This is user interface code right here. Then restarting the game will be the responsibility of the game. Then making a move will be a responsibility of the game again. In the UI, the user story said that they wanted to see names of players. So there will have to be a home and away player exposed by the game. And that completes the UI. Observe that I was analyzing user stories bottom up. From the most detailed ones, I'm building the large one. But when it comes to code, I want to develop it top down. I want to start from the outermost parts of the system, from those that are displaying the change I'm working on, and to model internals that are satisfying that change. In that way, I will go straight to the definition of done. So this was the requirement. Show me the names of players. And there was another requirement, nothing in the way the game unfolds will change. So that is this part. Really, nothing will change. There will be a restart and there will be making moves. So this is the shortcut to satisfying definition of done. And then we introduce an empty class game and see what to do with it. Where are you? Okay, here it is. There was a request to expose a board. Here is the board. Board will be initialized privately, and UI will have access to it so that it can draw it. Also, there was a request to restart the game. So here it is. Internally, I will just create a new game object, nothing more than that. And that brings us to players. What are the players? I will introduce an interface for a player, since there will definitely be multiple implementations of that. This will be bare minimum of having a player. It will just tell us the name. If you go back to the UI, where are you? Here. We expect home and away player which have a name. So we have solved the name part. And let's solve the home and away parts. Game will expose the two players. And now we come to the question, how do we instantiate those players? That is the interface. We have no implementations of that. But observe my top-down development style. I have completed the UI, which only depended on the game object. I have completed the game almost. The play method is missing, so I cannot play the game yet. And I'm going one level deeper into details to model the concrete players so that I can instantiate the game. But this, all I do, has nothing to do with the UI. UI is done. Okay, so player. I want to model a human player. I will introduce a class named human player, which has a name human, and that is the entire model. And I will initialize the players to 2 human players. Right now, I want the entire gameplay to remain the same, so I will play against myself. Which brings us to the play method. This is the UI code. Game must expose play method, which returns the new game, which will be used to render the UI. Okay, so play. How do we play? Okay, we will start from the current player. Whoever's move it is, please play. And the current player will be either home or away, depending on parity of moves made on the board. So we will need help from the board. Let's see. This is the moves count of all the moves played so far. So we will be able to count, to calculate parity and choose which player is home. And then we will ask that player model to accept the move, this move, because somebody clicked on the screen and we expect the model to accept that. So this accept method on the player will hopefully return a new board position. So we will just wrap that into a new board, into a new game state and return it to the UI. So if the player model could generate a new board for us, we will splash it on the screen. Okay. Let's see. The player must expose the accept method, which accepts the cell and the board, where to play on which board. So human player must implement that. How? Well, it will start from playable cells on the board. Those are the cells that could be clicked. Find the one that was passed to it as the one that was actually clicked, and play that cell. Otherwise, if there are no cells available that were passed to us. That must be a bug in the UI. We have nothing to do with that. We simply return with default to the existing board, so there's no move there. And we pick the first successful hit, it's done. So it will either play on this cell position or return the same unchanged board. And I can run the application and verify the definition of done. Come on. It seems to be working. So we're completing the user story. Where are my slides? We'll complete user story number 2. And now we switch to user story number 3. So this one is closed and the user can verify it and close it. And now we want to implement a dummy, the stupidest of all computer players. So we need a different kind of a player. Computer players will not accept moves made from the UI. So I will pull this out into a separate interface, which will model the interactive player. All the code I made so far about humans will only represent interactive players. And now we come to the game, and the game doesn't compile anymore because it assumes that there will be an accept method which doesn't exist anymore. So I will substitute that with a feature called make interactive move. And now we have prepared ground for a move which is not interactive, which is a computer. So as I do that, observe how small steps I'm making all the way through. That is why I know that I will deliver every single user story I mentioned here. This is the user story asked me for the simplest of all computer players. Here is the simplest one I could imagine, the one which always plays the first cell that is empty. Okay. It will play by starting from playable cells, trying to play any of those, okay? Falling back to the existing board if no empty cells are available on the board, either because somebody won or all cells are taken, and take the first one successful. This is the dummiest computer player I could imagine, a single expression. And I will introduce a separate interface which models automated players which have this try play. Compare that to accept. So we have two kinds of moves. One is to accept what somebody clicked on the screen, and the other one is to genuinely find out a move to make without anybody's help. And now the game must choose. I will introduce another make automated move and method which is only trying to access try play if it exists, and if it doesn't exist, it falls back to the existing board, so it doesn't make the move. And look at this. I want to make a full move. When a human plays, I want a computer player to respond. So I think this will complete the user story. There was a bit of complication here. Again, don't read the code, but notice how complicated it has become. That's what I wanted to tell you. All this development is slowly getting out of hands. And that is the reason why you want to break work into small user stories. So I will replace human player with the empty player, with not first empty player, the computer player, which plays the empty board. I will run the application and you will see that it will actually respond. There will be a bug, however, which is only around the corner, because customers are fine with this user story. They're accepting to close it, but they have another idea. They say, okay, whenever I restart the game, I want to see players switched. So technically I have made a bug here, which is not visible right now. The point is, when restart happens, I want to switch the player. So who was the away will become home and vice versa. If I run the game now, you will see the bug, which was part of the previous user story, but nobody could see it. And that is the reason why you want to break work into smaller chunks. Here, everything works, but if I let computer play first, computer will not play. Only after I try to play as human, my click will be rejected and the computer will play. The bug is that the first, when the game is restarted, there must be an autoplay triggered, because the first player could be a computer. And if I run the game now, you will see that this will work and this will work. Computer is really playing the first. So by walking in very small steps, we can close one after another, one user story after another, and we can finally start implementing the intelligent computer player. Here, I will implement the Minimax algorithm, which I'm not going to explain to you here. It is one of the most beautiful algorithms. It is used in adversarial games. So when there are two players playing against each other, every player may try to maximize own gain while at the same time minimizing the gain of the opponent. And that is why this algorithm is called Minimax. You can read about that algorithm on the internet. Here is the entire implementation, very simple, or not very simple, very short, but very complicated. And I will substitute the new player for that first empty. So this time we have an intelligent player, and I will run the application hoping that all the user stories will be closed. The trouble is that they will not be. Come on. Here's the thing. I have clicked and nothing happens. If I waited for a minute or two, you would find that this computer Minimax player is really, really playing smart. It's really working. The problem is that its performance is poor. So if we had 5 or 10 minutes longer to discuss this, you would find out that definition of done of user story number 4, having an intelligent computer player, is really done, but it is performing poorly. So customer doesn't want to close user story 1. They say, improve performance and then we will talk. And we do so. We do so by introducing caching to the Minimax player. This is board content compare that is required by the dictionary. Don't worry, just a technical detail. Anyway, here is the caching implementation. And when I run this, you will see that it will still be a bit slow, but don't worry. It will be much faster. It will be some 10 to 20 times faster than before. Here, it has played the corner so that I have no win. You see that this player is really intelligent. And as I said, that user story number 4, where are the user stories? It's really done. And now we have improved performance. Everything is closed so far, except the user story number 1. Because customer noticed that all games are the same, and they asked us to randomize. So I will add random generator. Minimax algorithm will randomize the moves, and the function will not return the best move, but the list of best moves. So again, don't read code right now, read it later. This is Minimax implementation with randomization. So if you want to learn Minimax algorithm, compare those two implementations and you will see how that can be implemented quickly. And here, randomized, you will have the randomized implementation. The game will be played differently every time. So again, we close another mini user story. And finally, the last user story. You will notice, if you played this game, you will notice that the computer player doesn't play the center, and center in tic-tac-toe is the only way for you to win, to guarantee victory. So let's do that, and we will finish all the work. I will add another implementation of the computer player, which will play the center if available. It will wrap around a different automated player for all other moves that are not center, and the implementation will be very funny. It will start from playable cells, seek the center. If it is available, it will play it. Otherwise, it will fall back to whatever the other player says. So any move other than center will be done by the Minimax player, and we will solve that here. Here it is. Player center uses Minimax player, but if center is available, it will play it. Otherwise, the Minimax player will take over. I will run the game, and now you will enjoy the completed program, which was done in very small steps, not in one user story, but in 8 of them. There is this phase of warming up the cache. But look, computer will play the corner always. It will never let me win. But if I let computer play first, computer will play the corner. And if I made a mistake, it will immediately start plotting the fork attack and it will win. If I played here, it will play the center. If I made a mistake, it will fork and win. So we really, really have an aggressive computer player. And finally, we can put everything on a table and ask the customer if that is all they wanted. They say yes, they will complete definition of done of this user story. We will open and open the user story and let the customer verify it. And when they do, as it all does all we wanted, all they wanted, this implementation will finally hit the production. So instead of working on a single user story, I have broken it down into 7 other user stories and worked on one after another. And as we progressed, we had added requirements. We have refined requirements that nobody could know while the first user story was the only one we had. And if we committed to deliver user story number 1, we would probably fail to meet the deadline because there were a couple of roadblocks along the route. So this was all I wanted to show you. Download code, read it, and compare it to this list of user stories, and you will see how it evolved. I didn't see any questions. Was it because this code was so scary or something?
Zoran, I don't see any questions either. Honestly, for me, this was a bit scary because I'm not, expert in the subject matter. But thank you very much. I particularly appreciated the breaking down of, one big story into several stories, of understanding the problem through going into chunks, into bits and pieces, and then trying to paste it all together. And I'm sure that there will be some questions pouring over later. So if you can check the Q&A session later, Zoran, would that be doable for you?
Yes.
Okay, awesome. And just to wrap up, you told me you were a cat person. And if I understand properly, you've been having cats all your life. I'm a dog person. And it's not only that they make my life really, really nicer, and with better quality, I also get to learn a lot from them. A lot about unconditional love, a lot about, perhaps not patience. That is, I would say, more applicable to cats. But is there anything that you learn from your cat, other than stacking the toys? Is there anything that you learn from your cat that you can apply in your everyday work?
Oh, yes, of course. For one thing, they are goal-oriented. They know precisely what they want to do. They never do more than that. And I think that is a virtue in programming. One of the most complex virtues to attain as a programmer is to learn what code not to write.
I really like this perspective, removing the noise, right? That's
Yes.
very, very applicable. So kind regards to your cat. Very, very big thanks to you. Thank you so much for sharing this with us and for being so plastic and illustrative with your presentation. So we'll be hearing you, seeing you at the next Scrum gatherings, regional or local. And yeah, we'll be reading some of your articles, I assume, as well.
Yeah, thank you very much.
Thank you, Zoran.